So I'm going to keep things real and talk about some real-world knowledge graphs that are in use today using Neo4j's graph technology. So what do these two organizations have in common? Anyone? Well, no points for guessing, but both of them use knowledge graphs for their business today. And on the left, you have NASA. And on the right is DZD, which translated into English is the German Center for Diabetes Research. So NASA has a 50-year-old history of space exploration. And they've got, in that span, a lot of incidents have occurred. And each incident, they do a root cause analysis. And this is across all departments of NASA. So they've got a host of knowledge locked up in these silos. And when they launched the Mars Orion program, they wanted to bring these silos together. And so they built this lessons learned database on Neo4j. So they can search for any term, and it can basically bring back the intelligence connected to the different incidents and to other incidents and so on. So they have saved over 2 years of 2 man years for the Mars mission already, and multiple $1 million as well. DZD, on the other hand, a similar kind of knowledge graph, but obviously their domain is different. So they've brought in all the research that they've done around diabetes, the different experiments that they have done over the years. They couple that with third-party data and market data available on the disease and put that together in a knowledge graph. And that helps them answer questions like, what does diet and exercise have to do with the disease, right? Are there regional or age-specific differences? Which genes play a key role in the type of diabetes? And also, what is the correlation of diabetes to other diseases, right? So these are kind of the questions they're trying to answer with this knowledge graph. So you saw 2 different knowledge graphs there. One was for search, another one was for discovery. Here's one on the left for e-commerce that eBay has deployed. This is a shopping application, a shopping bot that is available on Google Cloud today, and essentially uses context. It extracts context from your spoken text, or spoken words, and your written text, and basically couples that with what it already knows about you as a consumer to recommend products to you, right? And it uses NLP, obviously, to do that. On the right-hand side is the Panama Papers. I think a lot of you would be familiar with that. And this was a large leak of more than 11 million documents from a law firm in Panama. And these documents were then ingested into Neo4j. The context around those documents were linked together within Neo4j, and it basically unearthed a lot of politicians, officials, important people that were committing financial fraud, money laundering, et cetera. And it's still going on. It has netted already 2 prime ministers and a host of other people, right? And this is kind of another one in the Paradise Papers came on after this, and this stuff is just ongoing. So those are some of examples of knowledge graphs, but what is a knowledge graph, right? How do you differentiate a knowledge graph from a knowledge base? When you have a fact or knowledge, and that is put into a flat structure, there's static content, essentially a fact or knowledge is static content. And when it is put into a flat structure, when you search for it, you get back the same knowledge, right? But when the same information or knowledge is put into a dynamic structure like a graph, when you search for it, you now get it connected contextually to all its neighbors, and those neighbors are connected to its neighbors, and so you get much more rich knowledge that is almost intelligence. It is intelligence at this point. And so as new pieces of information or knowledge get added to a knowledge graph, the value of the overall graph grows exponentially. And so this then helps you predict things, sometimes not even the human brain could have comprehended that what is predictable and explainable through this type of a process. So going into the knowledge graphs a little bit more, I use this framework to help me evaluate whether something is a knowledge graph or not. So these are what I call the key principles, the 4 pillars. So obviously, the first one is more around connecting the facts together in the right context, and a lot of people have talked about that. Also, the graph needs to be dynamically updating. You cannot use humans or each piece of data as it's coming in, have manual intervention to do that. So you need to have some techniques and machine learning techniques to auto-label, to auto-populate the graph and connect it to its with the right context. The third thing is explainability, and this is key from a graph perspective, because all the traversals and all the questions that you're asking a graph are very, very easily explainable, because you know exactly how you traversed to that answer, right? So that's another key aspect of a knowledge graph. And finally, you're basically connecting structured, unstructured, time series, a whole bunch of different type of information together to form this graph. So I think those are sort of for the 4 key elements that I believe constitute a knowledge graph. So moving on, let's talk a little bit about a financial services knowledge graph that we're building right now. And we call this the risk management solution framework within Neo4j. And what we've done is we've brought in corporate data, company data, and market news from Refinitiv. Tim Baker spoke about Refinitiv earlier today. So we brought in that data. We've coupled that with market data available on stock prices of various instruments, things like that in the marketplace, ticker symbols. And then also we've mimicked a lot of corporate data, so data around trading desks, funds, loans, and you'd have so the positions data and so forth, right? And so some of the use cases that's possible with this type of data is credit risk management, where it's basically a causal graph. So we're mimicking some commodity price changes and fluctuations and how that impacts organizations through the relationships that organizations have with each other in terms of suppliers, competitors, ownership relationships, contractual relationships, and how it winds up benefiting banks and the loans that they have outstanding to some of these companies that have nothing to do with the commodity in question, right? And this could be like 6, 7, 8 levels deep. And this is a real problem with banks today. And this type of system is being used today by Itaú Unibanco, which is one of the largest banks in Latin America, and also Shaved, which is an Italian firm. Here's another example, an investment risk management, which is we've simulating trading desk and funds of funds and how they're connected to the underlying securities and their market prices. And we sort of track that whole lineage. And we're able to compute risk at the trading desk level within seconds dynamically at that moment. And we're also able to then handle compliance regulations, some of the upcoming compliance regulations as part of Basel IV. Here's another example. This is a portfolio news recommendation, and I'm going to give you a demo on this shortly. So what we're doing here is, you have a lot of financial service analysts that have to deal with a lot of news stories. It's a deluge of news every day. But they're only interested in certain stories because they follow a certain set of companies, part of their portfolio that they're following. They're also not interested in all kinds of news. They might be a legal analyst. They might be an analyst more focused on compliance, or somebody that's more focused on technology. And so they have more different topics of interest. So we have a recommendation service that recommends the right news articles to them. So this is the data model associated with this use case. So you have the user, which is basically the analyst, and they have interest in topic groups. They follow certain organizations, and you get the idea. This is the architecture for this solution. So what we are doing is we are pulling in a graph feed of organizations and the relationships of these organizations with one another. We're also pulling in news feeds. This is all coming from Refinitiv. We're pulling in real live news feeds from the market. And we're basically tagging this news with the right topics and the right organizations using NLP, using Intelligent Tag, which is another service provided by Refinitiv. And we're recommending these news stories that are score-based. So we actually score the news stories based on how relevant they are. And we actually remove a lot of noise from these news stories. So for example, there's constant news about Apple, Amazon, and the whole FANG stocks, right? But just the fact that there's more news doesn't mean it's more important. So we actually do some things to eliminate that noise. So we have small companies and large companies at equal footing in terms of the news and the importance of it. So with that, let me go to the demo. Just bear with me a second. So I'm going to log in as an analyst. And boom, this is real-time calculation of these scores, right? So you're getting this news, which is today's news, nothing stale. This is a live system. It continuously digests the news stories. So if you look at the first piece of news here, you can already see it's related to those different companies on the right-hand side. And it gives you a score for each news item there. You can actually click on this news story, and it'll take you to that particular piece of news. You can click on the score, and it'll give you an explanation of how that score was constructed, right? So you have the news story, and then you have its connection to the different organizations and its connection to the topics of interest, right? And conversely, you can also click on an organization, and it can point out the news stories that it has recommended based on an organization. You can also sort of change the weights of what your interests are. So let's say you're not so interested in financial services or capital changes, but very much interested in legal issues, mergers and acquisitions, and so on, and labor. And you can see the story change immediately. The recommendations are changing immediately. So what's happening in the background? Let's look at the data a little bit. So this is our Bloom product. This is for visualization and ad hoc querying, and it uses natural language. And it just right now I'm just going to show how it's going to use labels. I'm looking for this analyst. So I find that analyst by just searching for his name. And then I'm going to look for topic groups. So you can see this analyst is interested in the following topic groups. And that corresponds to all of these topics, right? Then let's look at the organizations that Harland is following. There's about maybe 20-odd companies that Harland is following. And then what we're doing is we're not just looking at the organization itself, but we're looking at the organizations and their relationship to other organizations. There might be a news story that impacts not the organization they're following directly, but second level out. And we appropriately weight that story and then return it back recommend it back to the analyst. So let's look at organizations 2 levels deep. You can see this data set is about 2.5 million companies, and just Harland it needs to deal with so much data that it's crawling through in real time to produce these recommendations, right? And then if you look at articles, that's even more data, right? So this is what the system is crawling through in real time in milliseconds to give you a response, and that's the power of Neo4j. So that is my demo, and that's my presentation. If there are any questions. Obviously, in conclusion, I would say that knowledge graphs are real, as you saw, and they are here to stay. And you take your static information, take your knowledge that you have in your different silos, pull it together into a knowledge graph, and get more out of it, get more intelligence out of the knowledge you already have. And we're hiring, and we're growing, so.
And we have time for 2 questions.
Thank you so much for this amazing presentation. So I actually wanted to ask about the similarity graphs. So while constructing the similarity graphs, like how do you manage the time dimension? Like, for instance, if you have a market data, like the objects that you have, all the financial instruments or whatever the object that you have, and then you want to find the similarity not just because from the static data, but from the market data, which is a time dimension. And then do we need to store the graph, like in Neo4j, for instance, like the couple of dates, and then go back and then check those similarities, or like we need to store the data in a way, I mean, like how?
Yeah, I get your question, yeah. So there are many techniques to model time. There's obviously time series. You can do a time series. You could do a hierarchy of time, right? You can also model a next relationship where you don't really have to model time necessarily, but you can have a time node and you can have a next relationship on that if your data is serial, if that is well known. So the different techniques to model time, it depends on your particular application and your use case, and I'll be happy to talk to you more about that.
One more question. Oh, Tonix, you said it's over. We said one more question, so a quick question.
Thank you. This is the question saved for me. Okay, so I just want to get your opinion about when I saw you rated the news, to like 12.9, 12.2 thing. Very interesting. Basically, you try to define which one is more important than the others, right? So I understand you probably assign weights to different contents or topics. Then when you combine these things together, do you have a certain formula to combine these scores, or do you simply take like a mean or average? Like, I just want interested to know what is the formulation, if you have any.
Yeah, it's a little bit complex, but I can go through a couple of the steps there. So one is we take the number of paths into account. So the number of paths connecting the source and the target, we take that into account. we normalize the news in terms of if it's Apple and the average number of news stories per day is X versus some other company, and what is their average, and is the news day today more than average or less than average? So we take that into account. And then we weigh the relationships. So first-level relationships are more important than second-level relationships with companies. So all of that is taken into account to calculate the score. But it's a relative score, as you mentioned.